Hey friends, Vincent here. Welcome to CRC in Rust, where we keep Rust clean and simple. Let's get into it. Today, we are doing integrity checks the hexagonal way. CRC-32 error detection on telemetry ingest in RustPulse. The goal is simple. Detect created or modified request bodies at the HTTP edge before we deserialize JSON or hit the use case, without polluting the domain with transport concerns. Here's the promise in one sentence. We validate bytes at the boundary, and the core still only sees a clean telemetry domain object. Alright, let's work the RustPulse code and make that concrete. So part 1, where CRC belongs. Here the router wires the HTTP adapter in, including the ingest route via HTTP telemetry handler ingest routes. That's the point. CRC is transport level, so it lives where transport lives. Then, in telemetry handler, ingest routes defines the endpoint, post telemetry. Then, at this location, the handler is instrumented as ingest telemetry, still an edge concern. And as you can see here, the use case takes telemetry, not bytes, not headers, not CRC. And here the domain itself. Telemetry stays pure, CPU, memory, timestamp, extras, no checksum field, no CRC-32, no HTTP baggage. That's the hexagonal mindset. The core stays portable and adapters handle edge-specific validation. So now, the part 2, the HTTP contract. Here, parse CRC-32 header reads CRC-32. If the header is missing, it returns OK none. So CRC checks are opt-in. Here, it accepts an optional OX prefix. And here, it requires exactly 8 hex digits, 32-bit CRC. So, the client contract is send telemetry JSON as usual and optionally add CRC-32 computed over the raw body bytes. Okay, now the part 3, the actual CRC gate. At this line, we parse the header first. Then, we read the body bytes, and it's bounded by the max body constant at line 22, as you can see here. Okay? Then, let's go back here. Now, the gate. If the header is present, compute CRC and compare. And on mismatch, we emit a log event with CRC check fail, and we return CRC mismatch immediately. Only after CRC passes do we deserialize JSON and call the use case. This ordering is the whole point. CRC is about validating bytes on the wire, so it must happen before parsing into a structured domain type. Now, let's see the part 4. Error responses are explicit. Telemetry ingest HTTP error as dedicated variants. Invalid CRC for bad header format, and CRC mismatch for header valid but body doesn't match. Into response at this location turns those into consistent JSON errors. Invalid CRC and CRC mismatch, for instance, with invalid JSON also and ingest fail. So clients can program against stable code values instead of scrapping strings. Now, the part 5 tests prove the behavior. So let's go down to the test port. right here. So this is a test module. And first, at this location, yeah, right here we can see no header still works, backward compatible. It returns 202 accepted and ingest is called once. Then right here we have valid CRC works, and further we have wrong CRC fails twice. Then we have at the end it returns 400. Ingest is not called, and we assert the CRC checked fail event was emitted. So the system stays backward compatible, but becomes safer for clients that opt in. Okay, now the demo part. One success and one intentional CRC failure. I will run the backend, create a telemetry body file, compute CRC-32 over the exact bytes, then call the endpoint twice, one with the correct CRC and one with the wrong CRC. So first, in terminal A, let's start the backend. Okay, now in terminal B, I will create a body JSON file with a sample telemetry payload. Now I compute the CRC-32 of the raw file bytes. I will use Python zlib CRC-32 here just for convenience. So let's do that. Okay, and now it prints 8x digits. That's exactly what the server expects in X CRC-32. So now the first call. Correct CRC header. This should return 202 accepted. And here, by the way, you can see as a CRC value, I just paste the 8x digits. And there it is, 202 accepted. That means CRC matched JSON post and the use case was called. Now the failure call. I'm going to intentionally lie about the CRC. Same body bytes, wrong header, this should fail fast. And now we get this kind of error with code CRC mismatch. That's the server saying, I received bytes, but they don't match the checksum you claimed. And if you look at the code, right here in 86, tag, this happens before JSON parsing, right here. Okay, now let's wrap up. So, the clean hexagonal integrity story is the app accepts telemetry ingestion as JSON, same as before. If a client wants extra safety, it sends a CRC-32 header. The HTTP adapter validates bytes and fails fast with stable error codes. And the core stays clean. Use cases still take telemetry, not HTTP headers. That's how you stay fearless. Clean boundaries, safer inputs, and a core that doesn't know or care about transport details. Thanks for your time. See you there.